So module 5, let's do something a lot like we did in module 4, but with some key differences. So let's create the 5 foot by 5 foot by 5 foot cube first. And if you were starting from scratch, by now you should be able to do this pretty quickly. You're going to use the rectangle tool, start anywhere, move in any of the 4 quadrants, type in 5 foot, 5 foot, click enter. It creates the 2D surface. Switch to the push-pull tool, select the surface, move in the up direction, and then type in 5 foot, enter. So that's how fast it should take to create a simple cube. Now let's say we actually wanted to make this one a 10 foot by 10 foot cube. You could obviously start over, but from here you could also just make 3 commands. Move one of the side surfaces out 5 feet with the push-pull tool. Move the other one 5 foot as well. And then move the top 5 feet up. Now you've got a large cube. There's one more way you could have done this as well. If we go back to where we were. If you select the entire cube, you use the scale command, and that's all the way, where is it? Right here. The shortcut is S. And this allows you to scale in a variety of ways, but if you were to select a far corner, then you could then move inwards or outwards. It's confined to 2 degrees of freedom here. If you were to start making it larger, switch over to the keyboard, and you can see the bottom right is asking you to specify scale. You could just type in 2, enter, and you got your 10 foot by 10 foot by 10 foot cube. From here, we could do what we did before to start modifying this object. But if we wanted this to simulate real architecture, one thing you might have noticed as a problem in the previous module is that everything is paper thin. And of course, in real buildings, nothing is paper thin. So one thing we typically do in SketchUp is simulate thickness. And just imagine that we were to make a box within a box, and then the space between the 2 boxes is treated as solid. So how would that look? Well, one really helpful tool to use here is the offset tool, the one over here. And the shortcut is not O, because O is for orbit. The shortcut is F. This is going to function like the push and pull command, where you're hovering over existing surfaces and they're sort of prompting you to manipulate them. But you'll also notice that when you're on a given surface, it looks like there's an edge red dot, which is sort of tracking your motion. And it's giving you a sense of which bounding aspect of the surface you're about to manipulate. The important thing is that you're going to be manipulating the bounding perimeter of the surface. So you click anywhere on, let's say we want to use the offset tool on the top of this cube. You click at any point on the surface. And now, as you move inwards or outwards, what you're doing is basically creating an offset of the square perimeter, either smaller, so it's within the surface, or it's even without of the surface. So what we're going to do is offset inwards, and here again, you can specify the length of this dashed line that's been created from the red dot. Let's say we wanted to make 1 foot offset inwards, and we're going to start the command towards the inside, switch off from the mouse to the keyboard, and type in 1 foot or 12 inches, enter. And what you've done is now you've created a new square inside of the old square, which is of course made up of all the same pieces we've been working with. You've got lines, you've got surfaces. Of course, now you have 2 surfaces, and they can be manipulated separately. So what we're going to do now is actually push the inner surface all the way down to the ground. You know that distance is 10 feet, but we can also align the push and pull command to any existing object in the space, which happens to be at 10 feet as well. And since the movement of the push and pull command is confined to that normal vector, either up or down, then in a way it's a lot like using the up, down, right, left lock commands, which means that you can also specify however high you want this, high or low you want this surface to drop. Let's say, for just example's sake, we want this to drop directly to the height of this character's head. This would be pretty hard to measure, but since we know where we're starting and we know that we want to, we're in a sense locked to the blue axis, then we can just move our cursor over to the top of this character's head. And you'll notice that the shape itself tracks you exactly. So So you can just click there and it will have depressed this square down to exactly that height. By the same logic, you can snap to anything you see on the SketchUp world, which is exactly on the ground plane, any part of this outer edge, any of the corners of this cube, and even from within, at some point, it will give you a blue, which means that it's hit the bottom of the cube. It's hit what you see right there. And if you use any of those, or you just type in 10 feet and click, then you will have deleted the inside because it will have hit another coplanar surface and canceled itself out. So what's happened here? This actually now looks like a hollow box with a thickness, and that thickness being 1 foot. Now, of course, don't be fooled here, because if you deleted any of this, you'll notice that that, of course, is also hollow. But for the purposes of SketchUp, what you're doing is creating a simulated thickness, and that's a really valuable thing to immediately begin doing at all times if you're going to be simulating buildings. So you do another offset. Let's do it from the edge. So let's do something like the window again, and let's offset 3 feet instead from the edge. And here, if you push inwards and catch the inside face, and of course, there's many ways you can align. You can align to this top rim, you can align to one of these corners, you can turn this around and align to the inside, or you can type in 1 foot, but it will cut through. Now, if you did anything else, it wouldn't cut through. You have to go to exactly 1 foot inwards. Any other piece, even outwards too much, inwards too much, I'm sorry, will not do that canceling effect. So you want to be exact there. Finally, let's do the door again. And so let's, just like before, let's create a guide measurement. Let's say 2 feet. From here, now let's make a real appropriately sized door. Switch the rectangle tool. We've created our guide node 2 feet away from the corner. We're going to start a rectangle there, move upwards in the direction we want. Notice that at the bottom, the inputs are going to be the height and then the width. Switch to the keyboard, type in 7 foot, comma, 3 foot, enter, and you've got your door. And now we're going to switch to the push-pull command. Now notice you can do pretty much anything at this point. And you'll notice also what's happening to the bottom perimeter shape. It's getting cut into or outwards. We're going to align to the inside or type in 1 foot, and then it's going to cut that door. So it's actually looking a lot like architecture. It's looking like you've created a real cut into the wall with an appropriate post and lintel. One more thing I want to illustrate here is if you came to the back side, one of the remaining 2 faces, and you were to create a square that was 5 foot by 5 foot, starting from this corner. You could, of course, do it with a rectangle command. But I want you to just notice, if you were to use the line tool, that you could snap on to the midpoint of an existing line, which will highlight as blue, light blue. And there, if you were to want to hit exactly the center of this surface, you could type in 5 feet because you know that exactly. But let's say you didn't know that and you want it to be right in the center. What you could do is hit the up or down arrow to align to the blue axis. And now you can move your cursor away from that and just trust that it will be a vertical line. And now you can use your cursor for the purpose of alignment to an existing piece. In this case, we can find the midpoint of the other face of the cube, which you'll notice as you're hovering down, it will sort of snap onto. And you notice that on the bottom right-hand corner of the screen, it's telling you that the line you're about to make is going to be 5 feet. You can go ahead and do that. Let's finish the shape, and then from here you can obviously push and pull that as well. Now, for sort of interest's sake, let's actually push inwards and see what happens. Now notice the canceling effect didn't exactly work, and because it wasn't a full cancel and it might be a little confused. Also notice that you've, in a sense, created an interesting cut of this wall. And so the push-pull tool is going to sometimes surprise you in what it can or can't do. More often than not, it's going to complicate things. But you'll have noticed by now that it's one of the most valuable tools we have in the software.